Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who are counting, this is episode number 139. Today, we delve into an increasingly critical aspect of technology and electronics manufacturing, the pursuit of environmentally responsible electronics manufacturing. Our industry has witnessed many environmental revolutions. The elimination of popular cleaning solvents brought on by the Montreal Protocol back in 1989, soon followed by strict VOC regulations pertaining to cleaning chemicals. The switch from lead-free base solders to lead-free alloys, led by the Restriction of Hazardous Substances Directive, known as RoHS, implemented within the EU in 2003 and adopted nearly worldwide. Regulations regarding the disposal of electronic waste, e-waste, resulting in many countries mandating regulations and programs for the safe recycling and disposal of electronic products, and so much more. These regulations and others have inspired some companies to seek eco-friendly alternatives to traditional printed circuit board fabrication. The combination of numerous environmental regulations has resulted in many companies' implementation of sustainability programs. As our world becomes more connected, the demand for electronic devices continues to rise, and with it, the importance of mitigating the environmental impact of their production. On this episode of the Reliability Matters podcast, I'll speak with Mark Edwards. Mark wrote an article entitled Environmentally Responsible Alternatives to Traditional PCB Fabrication, which of course spurred my interest. Mark works as a strategic account manager within McDermott Alpha Electronics Solutions on the global business development team for circuitry solutions. Mark has been involved in electronics manufacturing since the late 1980s and brings a passion for process automation, circuit assembly, solder, fluxes, adhesives, coatings, and PCB fabrication, all with a focus on repeatability and reliability. Mark holds a bachelor's degree in mechanical engineering technology from Oklahoma State University and began his career at a defense electronics company in Dallas, Texas that was later acquired by Raytheon. Mark has uncovered trends and synthesized customer needs for electronic hardware in the telecommunications, defense, automotive, and industrial control segments in the Americas, and now globally in his newest role. Join me as we explore new materials and methodologies and innovations that are shaping the electronics assembly industry towards a more eco-conscious future. Our conversation with Mark begins in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Well, after that long intro, finally, welcome, Mark. I'm glad you're here.
Thanks a lot, Mike. Happy to be here.
Well, let's talk about two subjects which normally are not talked about within the same context, environmentally friendly and circuit boards. So
right.
One of the challenges I think that the assembly industry has with printed circuit boards is, I like to joke that, we tend to believe that boards are delivered to our factories by storks. They just fall magically from storks' feet with parachutes and they land on our loading docks. Clearly, if we look at the electronics industry as villages along a river, the village just upstream from assembly is fabrication, board fabrication. Yet we have little to do. The assembly people have very little to do other than purchasing boards with knowledge of boards and how they're made and all the various materials and all the various options and configurations and things like that. We are quite a siloed industry. And the same could be said that the board fabrication people don't really understand assembly. And certainly we know that component designers don't understand either, because they make things that are almost impossible to place and to assemble and reflow and all that, clean and all those things. So we are a very siloed industry. But my my very limited understanding of the printed circuit board fabrication business is it can be a dirty business from a chemical standpoint. It's basically a metal plating shop and drilling and all these chemicals and processes. It's not something that you would just go in and eat off the floor. It's not a sterile environment.
Would not recommend it ever.
Right. So to hear sustainability and environmental responsibility in the same context as fabricating circuit boards really piqued my interest. So let's, first of all, before we go down the rabbit hole of circuit board fabrication and how to make it a little bit greener, tell me a little bit more how you kind of got into this role, and particularly how you either migrated into or began, I'm not sure which is accurate, your career in the environmental side. I know that's not all you do, but certainly you have a strong interest in the environmental side. Tell me how you got there.
Sure. Well, I was one of those assembly people, Mike. That's where I started for sure. And the silo of circuit board fabrication was new to me, decades ago, right? I remember I wrote about this in my article. When I first walked into a circuit board fabrication shop in Dallas, small to medium volume, doing a lot of defense work, I was shocked at how much my eyes and lungs picked up on what was in the air. It was unbelievable. And some guys were saying, don't step here. The soles of your shoes might not last, right? So compared to what you might see in an assembly operation where there's a reflow oven out of whack and it's not vented properly, get a little smoke, right? In the air, circuit board fabrication was like you said, a dirty, wet chemical process with strong bases and acids and all kinds of noise and, wet process tanks. So very different. As far as how I got here, I picked up on sustainability a little bit when I was in the assembly world. And it was around, lower temp soldering and things like that on the board side, right? Now on the fabrication side, I would say I'd migrated into it. And what's happened, I think about when I was a young manufacturing engineer in the late 1980s, and your customers and your viewers here probably would think the same way. You think about a process, does it have capacity to scale? How much power does it use? How much floor space does it take up? What's the throughput? What are limitations there? Power, water, whatever waste stream, that's just part of the process. And it wasn't really that big of a deal. It wasn't water cooler talk, right? And now it's definitely become something that's elevated up the chain of priorities. So I migrated into it. It just happens that one of the technologies I'm an advocate for fits extremely well with what the fabricators globally, mostly in Asia, as well as the OEMs, the largest global brands that we might know in anything from mobile device to automotive, any place where there's a lot of circuit boards being made, OEMs are putting pressure on the supply chain. So yeah, I kind of happened into it really. I'm not a PhD chemist, not a chemical engineer, but I always think about reliability as the end game. And of course, customers want, performance, they want reliability, and they want to know what the cost impact is, and then is it available and where? Those are kind of the factors driving the conversation.
I'm glad you mentioned cost. I'm going to ask you in a little bit. I want to set up a context first about cost because, I have this working theory, the world according to Mike, that if it tastes good, it's probably bad for you. And if it works well, it's probably not environmentally responsible, right? So we make compromises all the time where if we eat something that's gluten-free or low calorie, we just know it's not going to taste the way we're expecting it to. And I think there's a perception, perhaps based on experience, that if something is if something's green, it just doesn't quite work as well. But we'll get into that because I would love for that not to be the case here. But let's first set this up. Tell me more about environmentally responsible alternatives to traditional circuit boards. Do these alternative circuit boards look and feel like traditional boards? Does it Is it a different subset of materials where it would affect the appearance? How would I spot, if I could, a quote unquote green board environmentally from a green board laminate color?
Sure. Yeah, good question. So in the case of, the focus of my recent article and maybe most of the talk today, I'm just talking about one step in the process. I won't go through all the steps, but typically there might be 10 to 20 steps to make a multi-layer card, many multiple layers of copper that form the traces. Some of the most complex examples could be 80 or 100 steps in a fabricator to get it done, shipped, and packed in a plastic bag with desiccant. So you wouldn't notice any difference. For example, just a standard sample card, if it has this alternative method of primary metallization, you're not going to notice any difference at all. You wouldn't see it on the outside. And that's one of the challenge maybe we can talk about later is since it's not something particularly focused upon by the fabricators or OEMs, it's incumbent on people like in my role to evangelize about this because it's there and available to use. And it's currently not something that people focus on, like copper weight, signal integrity, the color of the mask, the white silkscreen lettering on the board, all those things that's easy to see. So because of that, it's a little bit taller slope to climb on the hill.
Yeah, there's certainly so many different materials and processes that go into one circuit board. I think there's a lot of targets, right? So if you're into sustainability, if you're into green stuff, you've got to work. If that excites you, it's an exciting job to try and turn that industry green because there's so many aspects to.
That's right.
The metallization, the chemical side, the etching, the plating, all of that. Can you provide an overview of environmentally responsible alternatives to traditional PCB fabrication and their key advantages in terms of sustainability? I mean, it's one thing to say it's green or greener. Okay.
Right.
How is it greener? How does that advantage land on the user or purchaser of those products, on the world, et cetera?
Sure. Yeah, I'd say think about the drivers first, right? So large global OEMs have their goals to reduce greenhouse gases specifically, CO2. They also want to use materials that are less toxic. They want to create less water usage. They want to create lower amounts of waste generation from a process. Less power consumption, less chemicals if they can anywhere in a process. And they want to do this for not only the bare board, but for the entire assembly, for the devices that they use, for the cables they specify. They also want to use, less precious metals. That drives changes, people are considering for surface finishes, or I want to use less gold. And you see this on the assembly side a lot. Somebody's like, tell me if your solder paste does the same as the other one, for example, do you use recycled tin? Right. So there's all these areas that the OEMs are driving. And then on the fabricator side, it's exceptionally challenging because they're faced with restrictions at the site level where the bare boards are actually made on like water or power consumption. And I'll touch on that later, maybe if we talk about some case studies. And then if you really just get down to it, it's less power, less water, less toxic materials, right, is what's driving this. And one of the measuring sticks is the amount of CO2 that's generated for a particular material that's called out or for the process being used. And specifically, it's kilograms of CO2 is the equivalent that people roll up all these various differences. And with primary metallization, it's quite an advantage using carbon particle-based metallization versus electroless copper. It's substantial, the savings that can be had from that.
How do alternative materials used in eco-friendly PCB fabrication compare to traditional materials in terms of performance, reliability, and durability? This is getting to my earlier statement, where if it tastes good, it's probably not good for you. If a circuit board is fabricated in a green manner, in an environmentally responsible manner, does it work as well? Are there any performance differences that the user would have to know ahead of time? Does it have to be over-engineered to work the same way a quote unquote dirty board would work. Does that make sense?
Yeah, for sure. The test methodologies that people call out are IPC based. They're like TM-650.2.6. A few other things there, right? They're pretty common amongst the industry. And with primary metallization that I'm talking about today, the test methods don't vary. And most of the boards and cross sections that are evaluated, they're evaluated after the primary step, which is kind of an activation step for the copper electroplating. So there's nothing different that you would test for. You were typically looking for, cross-section, plating thickness. You're looking for resistance testing to make sure it can carry the load. Temp cycling, simulated reflow cycling, all those things, all the same things that people test for an assembled bare board, no matter what kind of surface finish is on there. They're all still there. The things that vary widely is, of course, the not invented here syndrome. If somebody at a large customer just hasn't used this method, right, there's a pretty big status quo resistance. And then usually the biggest OEMs, they have their own flavor of some of these standard test methods. But as far as reliability goes, the fun part of it is not only is it a green process step in the fabrication of a circuit board, but there's a couple advantages on the reliability side. Without getting into the molecules, I would just say that the crystalline structure lines up as good or better than electroless copper in many cases, which is the incumbent technology. There's fewer interfaces at the vias and things that people would know about if they're board designers or assemblers, the through holes and vias, exceptionally good grain structure. And then you get direct copper to copper bonding. You don't have this other interface with copper and palladium. So there's fewer things to manage.
Well, if making green PCBs was easy and cheap, it would have been done a long time ago. So I'm assuming that the reason we haven't introduced green technology, or at least pushed it and made it more possible to the extent we have today, I'm sure the reason we haven't done that before is because it's not easy. I'm sure there's challenges. So what are some of the key challenges and obstacles in adopting environmentally responsible alternatives, producing environmentally responsible alternatives in the PCB fabrication industry, and how can those challenges, maybe that haven't been solved, be addressed, and how have those challenges that have been solved, how have they been addressed?
Yeah, sure. Maybe if you bring up the first graphic, I'll just go back to kind of like what the market and the big customers are telling us, right? So again, OEMs are driving their goals into the supply chain. A lot of the suppliers, including us, we supply wet chemistry, both processes, by the way, and many others. They're getting pressured by the OEMs. And of course, as I mentioned, they're getting pressure from local site regulations from, municipal, provincial, regional, county, city, state governments, wherever they are on earth. And the OEMs are asking for reporting on, all the existing materials in the bill of materials for a given assembly, electronic assembly, board, housing, cabling, et cetera, to tell us, hey, Mr. Supplier, what's the CO2 footprint of this module or device or cable or wire or connector, whatever. So there's this compliance aspect of it. The more exciting and, long-term benefit, I think, to the industry is about innovation. And many of the key global suppliers that are fabricating circuit boards, they have to report to their OEMs on an annual basis and bring sustainable solutions. Not only things that the OEM may not have thought about, but if the fabricator has a better way to do the same thing that saves, again, power, water, chemistry, et cetera, they want to bring it to the forefront. The challenging part for the OEM is, like you mentioned earlier, Mike, sometimes the OEM will say, let's say it's the end customer. They'll say, okay, great. So there's a greener alternative for step 5 in 20 steps. What's the sacrifice, right? What's the trade-off? And if it's equivalent, do I pay more? Or if it doesn't cost me more, what do I give up? So that's really where it comes down to people making a decision and doing something differently or making a different call out in their process documentation for quality and reliability. that's where the rubber meets the road right there. Somebody at a customer has to make up their mind to spend the time to evaluate the alternative.
Yeah, we do a lot of work with military and aerospace, and they're not big on change, right? You've mentioned the "not invented here" syndrome. In those circles, and for good reason, if a change has to be made, there has to be an awful lot of due diligence. There has to be an awful lot of research and DOEs and all this stuff to justify the change. In many cases, they're still using through-hole. They're still using tin lead. I think everyone who goes to work in the assembly side in that industry are driving Chevy Novas, listening to their 8-track tape players. I mean, that's how much things don't change in that world. So, I know that's particularly true in military type applications, but some of that also filters down to the rest of us mere mortals, right? Even in the commercial side, it's working. Don't change it, because someone has to put a neck on a chopping block at some point and take responsibility for a change. So how has the adoption of greener processes for circuit boards and greener materials been accepted by the industry at large, given the fact that it does represent a change?
Yeah. Well, there's no company that I talk to that isn't concerned about it, and it's somewhere on their priority list. So it's pervasive. There's no question there.
Yeah.
Not everybody in the supply chain is ready for it. The asks, again, from the OEMs are driving the supply chain to kind of line up to either report on basic things or, bring innovation. One of the other challenges is around, the OEMs are trying to calculate the kilograms of CO2, of greenhouse gas that's generated for every device on their bill of materials, and they have some gaps, right? So if somebody says there's a new process, they're not going to go re-engineer what they've been producing for 3 years. They're typically going to integrate it and onboard it for next generation products. So I would say the companies that release more products in a given year are the ones that are acting a little bit more aggressively and in a timely manner to explore these options. And for example, some of the mobile phone companies that you and I know anywhere on earth, frankly, they're very proud of their environmental sustainability achievements, and they have 6 or 7 page environmental PDFs that go along with feature benefits, not on nothing but where they used recycled materials, where they eliminated gold, etc. And so the companies have basically worked to say we're green as a company, our products are green. Now the attention is more and more pivoting to the rest of the supply chain. So I'd say many of the big gains that somebody would say, well, we converted our plant from coal or natural gas fired electric power to solar. That's a big step. That's huge. If a fabricator did that, that would also be a big win. But there's still processes that are more efficient and that deliver on these goals for lower consumption and less power consumption, no matter the source, whether it's green energy or not.
Yeah, you actually gave me a good segue. You mentioned that, if someone went from coal-based to solar, that's a major impact, and that certainly reduces greenhouse gases and makes the world a better place. There's 2 ways to look at a green circuit board, green environmentally speaking circuit board. One is that it's using green materials, and the other is that even if it's not using green materials, the environmental impact on making whatever materials are in it can be lower. Even though it still might be using a quote unquote toxic material, it's made in a less toxic manner. So I guess that's still a win. So can you discuss the energy consumption and carbon footprint associated with environmentally friendly PCB fabrication methods compared to traditional methods? Not just the materials being greener, but the entire energy footprint, carbon footprint in alternative circuit board fabrication techniques.
Yeah, sure, Mike. In this case, again, specifically, I'm just talking about the primary metallization step, which is right before electrolytic copper plating. where most of the copper is built up. Some of the processes up and downstream, they require harsh chemistries, just like I mentioned in the article, right? And some of those probably won't go away in our careers. But if you're talking about direct metallization, some people call that direct plate. And if you're a PCB designer or an assembler or anywhere in the supply chain that you and I have been in for decades, there are some processes like direct metallization that have been around for, I guess it's coming up on 40 years now. Electroless copper, the incumbent process, has been around since the mid-60s. Very well proven. And I'd say the biggest four gains, and we can maybe look at the other photo here just to see where it's applied. Thanks. Okay, so on this slide, Mike, I would say this is kind of an approximate summary of the deployment of direct metallization versus the electroless copper alternative, which is the incumbent. You can see here it's applied on flex circuits, rigid flex designs, traditional rigid products, with or without high-speed materials, Teflons and PTFEs and LCPs and all the things that board designers deal with. It's also applied on high-density interconnect designs, which are extremely common, and a little bit in substrate like PCBs. But in general, you can see here it's a pretty wide application. As far as the main impacts, right, what somebody would say in a meeting room saying, okay, it's similar performance, might even have some advantages in reliability. What do I get out of this? And how does it matter for me as a fabricator? And how can I communicate this to the end customer or the OEM globally? A couple benefits here. One is the lines are just shorter. There's fewer steps. You might have 2 DI water rinses instead of 4 or 6. It might be 6 overall steps in direct metallization versus 15 in electroless copper. So you need fewer motors to drive pumps, fewer motors for agitators. Some of the process steps run at lower temperatures in degrees C, 5 or 10 or more degrees, so there's less power consumed. The other huge benefit is that the primary chemical tanks themselves last for quite a bit longer, so you generate a lot less waste coming out of the back end of the line. And it's really efficient. Direct metallization is a simple coating process versus a really complex bulk chemical reduction. So there's all kinds of advantages, right? Less power, less water, less chemicals, and ultimately people are measured in their locales or the fabricators operate on what they, either put in a tank or put to drain or what they can recycle. So there's some really, really great advantages. For the fabricator sees it most directly from bottom line and floor space, that kind of thing. The OEM also gets the benefit if they convert this or approve or accept it because it's already available globally, and that you can kind of check the box and count that as a win relatively easily. Since we're not talking about a process that just came out, years ago, we're talking about decades it's been around.
Sure. One of the reasons I asked that question is I had a personal experience with an environmentally responsible, sustainable fuel as it was marketed, and that was EV85. So I drive a General Motors product, and I can use either regular gasoline or EV85, which is an ethanol blend. It's basically corn, moonshine, basically in auto grade.
Fermented corn, right?
Yeah. And I was so excited because at the time it was probably just over half the price of traditional gasoline, and I'm like, this is great. I felt like I got a cheat code on a video game. I'm gonna save all this money, and I was very excited. So the average range on a full tank of gas in my car, I have a big truck and it has a huge tank. It's about 450 miles. That's average. So I filled it up. It said 450 miles to empty, like it would normally. I paid just over half the cost of traditional gasoline. And as I'm driving it, my distance to empty starts to go down much faster than the actual miles I'm driving. It's recalculating. And long story short, my range, normally 450 miles on traditional gasoline, when using EV85, came down to about 300 miles. So I lost about 150 miles of range using this environmentally, responsible green fuel alternative. And I actually calculated I'm a bit geeky when it comes to math, so I created this little Excel spreadsheet and I started keeping track. And I calculated that my cost per mile was either the same or a little bit worse, depending upon certain conditions, than the alternative, than the traditional conventional fuel. And then I started reading into, well, how is this stuff made? Well, it's not made on the same mass scale. Saudi Arabia is not producing 1,000 oil wells worth of EV85. These are basically produced by farmers in Iowa and things like that. And because it's not done on a large mass production scale, we don't have pipelines running thousands of miles across the country running EV85. They're delivered in trucks, in tankers.
Sure. And
the fields are cultivated with John Deere and Caterpillar tractors and running, diesel. And I started reading more and the carbon footprint to produce it is really no better, and in some ways arguably worse per liter. It could be scalable, but worse per liter in the small volumes it's made in, and its use is terrible. I would not run that anymore. So the point I'm making is sometimes going green, we have to go green to get the credits, particularly if you're a larger company. We have to go green to get the customer to buy from us, and that's got a cost associated with it. Fair enough. We all make those decisions every day on what to invest to get the business. But sometimes we get green results for free, or maybe even a savings. And it all has to do with scale, and that has to do with acceptance and things like that. Are we to the point today where we're at least parity with conventional methods, or is there still a little cost implication there?
That's an excellent question. I think about a couple other materials that they have like carbon footprints on some data sheets, for example, for PCB laminate. So, the glass cloth and the resin system that the copper foils ride on or in between. I don't personally right now, I don't know how many engineers or global procurement people would say, I'm picking this because it's green. But I would say what I've heard with my own ears for quite a while now is if the material or process passes the test that we normally require for this product, whatever it is, circuit board or assembly, the performance, metrics are there and doesn't affect signal. If all else is equal, which you and I have heard this term before, is if all else is equal, I'll pick the thing that's greener, as long as it doesn't cost me more.
Right.
And in this case, at least for this one step, it's generally a cost neutral or better kind of proposition. Some fabricators have this and they run the incumbent process right next to it. Just depends on what the customers require and allow. Some fabricators globally, they only run the incumbent process and they don't have direct metallization. So if somebody were to say, I understand, I've tested it, it looks great, I want to find it somewhere in my existing supply chain, one of their existing suppliers might have to add a line in there, right? But there's also a little bit of kind of what's in it for the fabricators if they use more of it, right? So there's obviously the savings in power, water, less chemical consumption, less waste generated. And you mentioned, mileage and efficiency of your vehicle. If you don't have to haul off as much waste and you don't have to truck in as many, pails and barrels of material, you're saving on the transportation aspect, right? So that's a net gain, which is pretty fun.
Sure.
And then all those activities still translate to savings in greenhouse gas emissions. And just to put a little definition to that, we're just talking about carbon dioxide right here, which is one of the most measured. But greenhouse gases include methane, nitrous oxides, CFCs, which have been regulated and reduced, for decades now.
That's my business. I was very grateful for that Montreal Protocol, which eliminated a lot of the CFCs, because that's what got me in the business that I'm in, the cleaning business. Obviously,
Yeah.
not the CFC-based cleaning business, the aqueous-based cleaning business. How, we talk about using materials that are greener, and we talk about that in context of fabricating the boards. What happens, though, at end of life, right? There seems to be a lot more emphasis and focus on what's happening in the world of e-waste and recycling and making our waste materials less toxic. So how does the recycling aspect of environmentally friendly PCB materials contribute to a circular economy? And what advances have been made in this area?
Well, I would say considering, the primary metallization is quite a small relative content by weight or volume in a circuit board compared to the copper plating and the surface finishes and the glass fiber and the resin systems, it's pretty small. The processes that are used currently to recycle boards and cables and extract, gold and tin and silver and copper, et cetera, I'd say it's very well defined. There's nothing that one would do differently that I can think of if they adopted direct metallization over electroless copper. Infrastructure is there and it's excellent. I've had friends that are in that space for a while. Hopefully it doesn't end up getting dumped off of a freight liner on the shores of, some place with people, less well off with no PPE extracting it. But I'd say the same processes that exist currently for circuit board recycling are there. There's one advantage, and that is since direct metallization in this one step doesn't use palladium, there's one less precious metal for somebody to go harvest and deal with, right? And since the process itself uses less toxic chemistries, wouldn't say that directly impacts the recycling. It more impacts what people do at the factory level for things that leave their building that's not on a product.
Yeah, we've all seen on the news lately these people in lithium mines,
Right.
pulling lithium out of the ground. And although the electric car companies, certainly don't like the image that is circulating around, the fact is there are young children and people without any PPE, as you suggested, pulling lithium out. And the same goes for other precious materials as well. These are dirty businesses. Most of our mines have closed years ago because they couldn't even legally attempt to operate in this country with OSHA rules and environmental rules and things like that. And that's kind of a very inconvenient truth. A lot of the materials we use every day are obtained through what some can consider illicit means, yet they're still required to make the world go round. That's a whole category of an episode right there that we can really fall down a rabbit hole right there.
Right. I've seen those videos, by the way, but
it's pretty scary.
They're heart-wrenching. People in, in flip-flops, essentially, with their bare hands.
Yeah, absolutely.
Doing open pit mining. It's crazy. I would say the other thing, just eliminating palladium from this step in the process, Mike, that's just one more thing. It's not only one less raw material to manage, but of course there's, price fluctuation issues with precious metals. But also for wherever that material is consumed, it's one less thing that becomes some sort of geopolitical football, right? If you don't have to call out something that is limited source on Earth, then you just, if there's geopolitical tension or wars or trade issues or whatever, just one less thing that the engineers and supply chain people have to deal with. So it's making it simpler as far as the overall process and the amount of materials that are used. It's a benefit for the OEM, the end customer, and the fabricator.
Yeah, that's a whole conversation. The fact that our defense industry runs on certain types of precious metals, rare earth metals, which are not mined here. And where do we buy them? We buy them from the people that were building things to protect ourselves from those people, right? It just, talk about a circular economy, that circular in the wrong way. What role do regulations and certifications play in promoting the adoption of environmentally responsible alternatives within the PCB fabrication industry?
I'd say the regulations play bigger with the fabricators, and it's the amount of waste materials that are generated, the types of things that are in the waste stream. When it comes to like the carbon footprint of materials or processes or components and whatnot, there's some good standards that are out now. ISO 14067, 14044, 14040, as far as, how to calculate these things and measure them and making sure that the data quality is there, et cetera. There's one thing I'm following now. It was maybe first kind of broached at Productronica in Germany in 2023. There's a new working group in the standards committees generating some framework for a standard called 2553, Sustainability for Electronics. I think that's going to help people in all parts of the supply chain, essentially coalesce the things that are important to them. And, standards help people spend less time trying to figure out what's important. So I'm all for this standard getting developed and built out. We'll be following that. There's a standard meeting in Barcelona that happened, and that's something we're going to watch, because IPC generally generates quite a bit of good material for assemblers as well as fabricators and all parts of the supply chain, the designers, the OEMs to follow. So I'm hoping that accelerates a little bit, because there's definitely pressure on the market to come up with things that are not these one-off standards and regulations. The fabricators, no matter what, even if that gets solved and 2553 helps everybody in the marketplace, the fabricators still have to deal with local regulations, from governments and restrictions on power or, water usage, those kind of things.
How can companies balance the need for innovation and performance with the environmental responsibility when choosing PCB fabrication techniques? It's got to work, it's got to perform, it's got to meet budget requirements, and it's got to be green. How do we balance that?
Yeah, I love that question. That's one of the most challenging things, right? I hear it from both sides, right? We talk to fabricators, which is where most of our chemistry goes. Some of the OEMs still have their own fabrication sites and are vertically integrated. But balancing the need. So it's all about, focus. Are the OEMs and the fabricators, are they going to focus on one particular thing for multiple years? So for example, I didn't mention earlier when we're talking about regulations and maybe the goals, a lot of these OEMs and large companies have goals to achieve a certain amount of CO2 reduction by 2030, some more aggressive, than others. And then by 2050, they want to be carbon neutral or even carbon negative, which is something I heard from Microsoft recently. I have to kind of do the math on that one to see if I follow that entirely. But yeah, the OEMs are, they're really, really pushing hard. And there's a shift here, Mike. It's from, this is something I think we need to think about for a company strategy. And then it's shifting to, our customers are asking us for this. We don't have it now. We have to figure out a plan to get it, generate this data on kilograms of CO2 for a certain material or process. And now it's shifted, and probably the biggest burden is on the fabricators and the assemblers, but specifically here with PCB fabrication, the fabricators are getting asked, demanded by the OEMs to not only explore and report on the existing processes that are used, but the fabricator specifically is having to put the CO2 impact of a production board fab quote on the quote itself before it's even produced. And because of that, the fabricators are going to push on everybody in the supply chain for wet chemistry and laminates and copper foils and silk screens materials, all the various things that go in there. So it's pushing hard down there for sure. And the good news is direct metallization versus electroless copper. It's one of those things. I guess I'm calling it an easy win. It's out there. It's been around for decades, and it just is another checkbox for fabricators and OEMs to say, okay, maybe it doesn't deliver the biggest impact in the scheme of the 30 things we might be looking at, but it's right under our nose. It's kind of like the low-hanging fruit. So as an advocate for the technology, essentially, that's how I position it.
Yeah, excellent. So finally, in your opinion, Mark, what are the emerging trends and future developments in environmentally responsible alternatives for PCB fabrication, and how do you see them shaping the industry in the coming years? So it's kind of crystal ball time.
Yeah. Yeah, I think, the shift will continue from this compliance and just reporting on the current state and the status quo to more people and, more stakeholders in companies. So this would be from DFM engineering teams, design for manufacturability guys, process engineers, product managers, ops managers, and more corporations have, sustainability stewards that are investigating in the supply chain, what they can deliver every year. And to me, something that's been a common theme throughout my career, whether I was a engineering guy or a technical salesperson, is always around, if you can show me some sort of improvement that delivers double-digit improvement or savings, or reduces something that's bad by double digits, I'll consider it. And to me, DM is one of these things. And sustainability in general, I think the more time that goes on, the harder it is going to be to get significant impacts, right? I think that's kind of like just in quality, right? Getting from 85% yield to 90 is one thing. Getting from 95 to 99 point something is an entirely different thing. I know you know this well.
I think it's the last mile that's always the most challenging.
Yes. Yeah. And I was on a call not too long ago with a fabricator in Taiwan, a very large global player. And they're like, hey, Mark, I'm going to show you the 100 steps that we have in this particular board design that we have to allocate the kilograms of CO2 yield based on the process that we have designed for it. And they have to do a lot of work, right? So the good news is the fabricators model their process. They know what goes into it. They just need the numbers. So that's the compliance side. The innovation side will be, what the market's asking for this, or we have water restrictions, or we have power restrictions. What can we do as a company without being asked by the end customer just to be better? And I think that's going to continue. So if they have the motivation just to improve for its own sake, and there's some benefit to the customer and the company that's offering it, I think we're going to do well. And if you add in IPC 2553 and some of the other regulations that might emerge, which the EU's done quite well with, I think it's going to help the industry focus in all parts of the supply chain. We're happy to be part of it too.
Excellent. Well, Mark Edwards, thank you so much for your insight and sharing this mysterious world of sustainability and environmental responsibility, mysterious as it applies to circuit assemblies and circuit boards, I should say, the fabrication side. As we talked about earlier in the broadcast, we've both been on inside fabricators, and you feel like you've just cut a few minutes off your life whenever you walk out back to your car, right? It's definitely environmentally heavy process. So anything, whether it's low-hanging fruit or major changes that we can make to that side of the business, the better. And I've long said, in my world, we're in the cleaning business, and in my world, we consider ourselves a green company. We have processes which have no drains, and nothing goes to drain at all. And I've long said that people chase two greens. When it comes to environmental sustainability, people chase two greens. One is they want to make the world green. They want to have a green planet. Awesome. The other is it's a savvy business move to be green. Even if they don't care about the environmental impact, the perception that they care sometimes is worth the investment. And in some cases, it's even a savings. We can argue there's a cost savings to being green, and not just a theoretical cost savings, not just the potential for lower liability, but a truly operational cost savings. So I think that's where this is all going. It's going from buying credits so you could do bad things, yet still call yourself green, to actually having the common sense conclusion that we should be more sustainable because it makes more business sense. That, I think, is where a lot of the industries are going. I think that's where technology is improving the consumers or the manufacturer's ability to become green. And it's an interesting journey. It's interesting to sit on the sidelines and watch.
For sure. Oh, and maybe if you could bring up that last graphic, Mike, I just wanted to point out one thing, right? This is a really good summary, a proxy for what companies, fabricators, as well as the end customers, the large OEMs are looking for, right? The OEMs kind of focus on the right side. The fabricators really live and breathe by the first three there.
And let's explain for our audience who are in the car, going, what's he talking about? There's 4 images on the screen from left to right. Go ahead and describe what those are.
Yeah, so obviously one is power. We talked about essentially the kilowatt hours per board square meter processed. And then there's waste treatment, how many materials come out the end of the line, how much input water is used, and then ultimately anything, including these power, water, waste treatment, roll up into CO2 emissions. And you mentioned one thing that's interesting as far as what you do about zero output. There are zero liquid discharge options available for this step in the board fabrication process that really take the water reduction from like a 70% savings to 99.5%, except for regenerating some holding tanks, essentially. So there's even bolt-on options to the existing process that can just kick it up a notch, especially if there's water restrictions or droughts or whatever, wherever the fabricator is. Some great options. So the process has been evolving over the last 40 years, and it continues to get better to advance along with the board design requirements out there for fine line and spaces and higher layers count, et cetera. It's really a neat thing to see, a company that cares. But just talking about the technology, right? This conversation is at the water cooler, and it's in part of what people get measured on year to year, right? Whether you're the supplier or the customer, doing the designs and putting out the requirements, it keeps getting elevated up the ladder. I wouldn't say it's number one.
It's not just the people hugging trees anymore. It is a corporate mandate, and for good reason. And if it's cheaper and people are doing it to save a buck, God bless them, right? That's great. There's no harm in that. Ideally, to get adoption, to get greater adoption, we really need both. We need both greens to be on the table. We need to have it
for sure,
truly environmentally responsible and a prudent business move that even a bean counter would agree that's where we need to go. That's what kind of what we're waiting on, and we're getting there. We're getting there. Not everywhere, but we are getting there. Well, Mark Edwards, we're out of time. Thank you so much for being my guest today and sharing your wisdom and your expertise. And thank you for helping me understand how something historically so not green can be more green. I really appreciate that perspective. And if my audience would like to get in contact with you, is it okay if I share your contact information?
Absolutely, Mike. Yeah, appreciate it. Thanks for having me.
And I'll be sure to share it in a green way. For my listening audience, once you're in a safe place, go to your favorite podcast app and look at the show notes, and you'll see Mark's contact information there. If you're watching this on YouTube, somewhere down here, it says show more or something like that. Click that button and you will be able to see the show notes, which will include Mark Edwards' contact information. So Mark, again, thanks for being my guest today. I really enjoyed our conversation.
Thanks, Mike. You're welcome.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thank you to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions or questions to Mike at mikeconrad.com. Just remember, that's Conrad with a K. Once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.